Hello everybody. So as I told you, we will have a long interview with Bernhard Münzing from Sixth Element, who will give a talk at the Applied Smart Materials in 2 weeks in Stuttgart. And here you go. You got about 16 minutes of good statements about graphene and its applications. Enjoy.
So, Mr. Münzing, we understand that Sixth Element currently produce graphene flakes and graphene oxide in plant in Chengzhou. Is that correct?
Well, that's quite correct, but we produce graphene, reduced graphene oxide and graphene oxide in our headquarters in Changzhou, and since April 2020 also in Nantong, so we have 2 plants. We have a total capacity of 1,000 tons per annum, and we offer graphene and reduced graphene as powder, in water, in solvent or resin-based suspensions. For that we work in Europe with partners. So GO offered is also, or the graphene oxide is also offered as a water-based suspension or a paste.
Oh, okay. So thank you very much. But so now my one question. So because graphene was getting popular with Andre Geim and you know all these activities in Manchester, what is your relation to this activity?
Well, you need to be aware that similar to Europe, China has also built up a kind of graphene flagship program. It's running under different names, but basically they're also trying to create an ecosystem in which the graphene producers, people who would like to use graphene, work together and create new products. Similar to what the European Union has done with the graphene flagship program and what is ongoing in Manchester with the cheek.
Ah, I see. Okay, thank you very much. And so if I see, so you know, I'm not so familiar in with China, but so I have some experience in Japan, and if I see the expenses in R&D in carbon nanotube, which is my background, in Japan are really much higher than in Europe, for example. How is the relationship China R&D expenses in graphene and Europe?
I would say that the European graphene flagship with the 1 billion euro is quite similar to what the Chinese also spend. The Chinese might spend this in a shorter period of time, but overall, I think that's quite equal. It's not too much less or significant higher. Yeah.
Okay, thank you very much. Thank you very much. Okay, so now one key question. So at the beginning, of graphene, so there was a lot of talk about transparent conductive films, barrier films, and many other applications, which were quite similar to the carbon nanotube applications, I remember. But now my question is, how do graphene change the product properties? And can you give some examples how you can improve product properties?
So basically, you have just mentioned that carbon nanotubes, of course, is still a competitor graphene.
Still,
okay. Yeah, because there are similar applications, of course, increasing conductivity, increasing thermal and electrical conductivity, working on mechanical properties. And at the end, it really depends what you're looking for and what you would like to have and in which context you do that. So carbon nanotube is not very good in corrosion protection because this is a tube and not a platelet. Carbon nanotube has some deficiencies with regard to the way how you can create thermal conductive films. Graphene, you can really have a freestanding graphene film, which is basically a kind of paper. And of course, if you go into the electronics part, with graphene, you're really able to build transistors using different CVD processes with different materials so that we really get a transistor, which is basically not possible with a graphene carbon nanotube. So there are differences, but in some applications, really both products compete against each other.
Okay, so are they in competition? And may I ask you, so this leads me to my next question. So do you have any target applications and can you name these applications? And if so, why these are your target applications?
So one target application which has been developed quite early was corrosion protection due to an incentive basically in China. And corrosion protection, I really do see some great benefits of graphene, combined with some synergistic other pigments, you can really achieve marvelous corrosion protection levels. Another one is heat dissipation, the graphene film. And then you see also in automotive, people using graphene in foams, in brake lines and stuff like that. So yeah, there are some projects which are really now coming into commercialization, or in rubber, not tires, but rubber buckets in mining industry, where you talk about abrasion, which is not that easy to mimic by, for example, carbon nanotubes.
I see. And so this leads us to the next question, which is very interesting. So can you name us any customers of you? And especially, as you know, we are located in Stuttgart. We are always interested in automotive. And so can you name some customers?
For 6 Element, the main customer at the moment is Huawei for the heat dissipation film.
I see.
And then we have some smaller companies using graphene for corrosion protection. Yeah. If I look a little bit broader into the industry, Ford is a customer using at the end a graphene-based polyurethane foam. Martinetta, I hope it's now right, pronunciation, is using graphene in a kind of brake system. It's a little bit difficult to understand exactly what they do. Because not so much is disclosed. And what you also will see, at least in prototyping, people start to produce sensors for different applications. There is a company in Spain called Graphene who is really good in that. And sensors, automotive look for sensors. And, so that's another step forward, using graphene in larger quantities.
And you are supplying to all these applications?
We are not supplying to people like Graphene because they produce on a CVD-based process. We are supplying basically into the so-called bulk materials to people like Huawei indirectly, in coatings, in thermoplastics, in tires, in cement, whatever you can think about.
So now I'm a researcher, and we always have to write research proposals, and then you check very frequently reports from Frost & Sullivan or IDTechX, where you see, and regardless if it was fullerene, CNT or graphene, they said the market will explode and everything like that. But I don't know, at the moment I don't think anyone was getting a millionaire by working with graphene. So my question is how you see the market potential for graphene and the growing potential.
So a lot of people at the moment say we are at a tipping point, and I would basically, yes, we are in a tipping point. So to go to the largest volume-wise, tonnage-wise application, we know so far it's really the heat dissipation film, where we talk about several hundred tons already, and this is increasing. We will see further applications coming in the thermoplastic and in the thermoplastic elastomer field sooner or later, also driven by the automotive industry due to electrical conductivity requirements and stuff like that, to combine with other properties they need to fulfill. And of course, it will take some time, because except of the Huawei graphene film, you mostly talk about something like 0.5%. Or less than 0.5%, really to have an impact on that. So then you can start to calculate how many tons you have to sell as a final product to get 1 ton out of it. But it's coming. You see that certain companies are investing in further capacities, and step by step, it's really moving. It's not going so quickly. And if you look at Frost & Sullivan and these numbers, you need to separate a little bit between the pure graphene and the products out of graphene, and that's not always really differentiated.
I see.
And we have not talked about the electronics part, which is a completely different field, because there you basically calculate by square meters. And you basically you sell at the end the chip or the transistor or whatever it is and not only one graphene layer, because it's more than that. All the sensors, they sell not only the graphene layer, but they sell as a whole system, basically on a wafer, which is already then really ready to be mounted.
I see.
They work in a clean room environment, as you know it from any other electronic company.
But this leads me, so you think so we need a bit of time, still for market development and everything.
We'll see that is coming. You know the qualification times of certain products, and yes, but it's moving step by step, slowly, but step by step.
But now when we're talking about qualification, one big thing, that we are in Europe, we are super concerned about HTC, health and toxicity stuff, and REACH. And so can you tell us something about the legals and certification and HTC and REACH certification about graphene?
So to make a long story short, the 10 tons registration, also including the nano regulation of European Commission or European Union, has been finalized, including the nano part, with the nano part last year in December, so up to 10 tons. So a joint registration dossier is registered, and the consortium, REACH registration consortium, is working now for 10 to 100 tons, and more than 100 tons is already on the screen, but it takes some time to run through all these different steps with labs. Asking, if you ask labs, it takes 6 months, 9 months to get results. So, but the major graphene players are working on that.
Okay. So you're on the way. Right?
Earlier than carbon nanotubes, for sure.
Yeah. So it's a fiber. It's a fiber. This makes it not very easy, to handle all these fiber-related issues in toxicity, and so. Yes, I remember all these hurdles we have to overtake, and graphene is really very charming in terms of their geometry. Yes, it's very charming because it's not a fiber, but this leads me to a point when you're processing graphene, for example, in a thermoplast, right? So, can you use an extruder to process graphene in a thermoplast?
If you do it right, you can do it. It's a little bit tricky. You need to have some knowledge, and you have a knowledge of that. IPA as a knowledge.
Thank you. Yes, because I remember the first experiments as we use graphene, or so-called graphene. Mostly it was graphene nanoplatelets. But when we started to extrude it, we simply make out of platelets, we make some spherical stuff by the shear forces. They tend to bundle, then the effect was zero. But if you are aware about the state of the art and you have some knowledge, then it's possible. Yeah. But now you read probably the article from Daimler about the graphene battery and what is the potential of graphene in electromobility, which is very important for us in Germany.
So you need to be aware that in Asia, LG Chemicals has already launched a battery with own produced graphene. In China, there are some graphene suppliers already supplying graphene to battery manufacturers, not as a complete replacement for other things, but as an additional additive to enhance cycle lives and perhaps also to enhance certain energy density. At the end, the whole question will be how you can combine the different things in the right manner to really get the highest energy density out of it. And also carbon nanotubes are in this game, of course, so it's a little depending on the formulation and a lot of other things. Graphene will be part of the formulation, but it will be not the solution as people think.
And when you talked about we talked about batteries and energy density and cycle life. This is very clear for me. But now when I see in the car of the future, the thermal management will be very important. And do you see, or which role you see of graphene in the field of thermal management in our cars?
So it depends a little bit whether you would like to have a thermal management and you don't care about electrical conductivity. Then graphene is for sure something what will help. We are working on some solutions on coatings. So to really create a thermal conductive coating which sticks also on the surface and not breaks away. And also on thermal conductive thermoplastic materials. But if you would like to have something which is electrical isolating, and in some cases you also need that, then you need to go to the 2D boronitride systems.
Okay.
It really depends whether you can accept electrical conductivity for EMI shielding or something like that, or whether you say, no, I need an isolator, and then graphene is not the right product to deal with.
Okay. But I feel it's, I feel this answer really is very professional from my point of view. So I remember in the carbon nanotube times, carbon nanotube was helping against every problem, every problem, regardless what was the problem. But now you made the boron nitride two-dimensional, which is really, in terms of thermal conductivity and heat dissipation and thermal stability, very, very good material. Yeah, we know this, and it's good to know what graphene can and what it can't, right? But so now very soon you will give a talk in our webinar, Applied Smart Materials. Can you tell us in 2 sentences what is your talk about?
I will basically present an overview on graphene and the market with some examples, not only from 6 Element, but from examples really now in the market, which are serial production. And then we hope that people then start to think about what they really can do, and that step by step people realize that this could be a good solution.
I see. Okay, so this I'm really curious. Yeah, so I'm really curious because I was following on LinkedIn your activities, and so obviously you are a celebrity, and I'm really curious about your talk and about the message you will give. And so then I think that's it for today. I thank you very much for this time, and so we are all expecting your talk in 2 weeks, and thank you very much.
It's 2 weeks. Yes, it's 2 weeks already, right?
Yeah, okay, thank you. Bye-bye.
I love talking with smart people. Isn't it interesting what he was telling us? And so he will giving his presentation at the Applied Smart Materials 1, which is about materials, on April the 13th, starting at 9. You can register at the IPA website. The webinar is for free, and it will be a good time. Maybe we see you there. Bye-bye.